Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about El Nino, La Nina and ENSO. In this lecture, we will be discussing on humidity concepts, importance and measurements. What are all the contents we are going to discuss in this lecture? That is, nature of humidity and its measurement, types of humidity, factors influencing or affecting humidity, daily and seasonal variation of humidity and importance of humidity. So, these are all the contents we are going to discuss in this lecture. First, what is meant by humidity? That is, humidity is the amount of water vapor present in the air. So, how much amount of water vapor is present in the air is considered to be the humidity. It varies with the temperature, pressure and also the location. So, if the temperature and pressure differs, the humidity content which is present in the air is also differing. And if the location, it may be a lower latitude or higher latitude, the latitudinal variation also influences the humidity amount. And what are all the influencing factors? That is, it influences the atmospheric stability and weather patterns, and it is also important component for hydrological cycle. So, without water vapor, the hydrological cycle, imagine how it will be. It could not function. So, this water vapor, that is humidity, plays an important role in hydrological cycle. So, water vapor in the atmosphere, it is not visible, it is invisible gaseous form of water in the air. So, can you see the water vapor in the air? No. So, only if the water vapor is felt in glasses or in the transparent surfaces, we can see the water vapor. Apart from that, it is invisible gaseous form. The maximum capacity depends upon temperature. So, if the temperature is high, what happens? It heats, and due to the evaporation process, the humidity, that is the water vapor, is rising from the surface of the earth. So, depending upon the temperature, this maximum or minimum capacity in the air, the water vapor content will be. And if it is going to be a cold region, there will be a low water vapor, that is humidity. If it is going to be a tropics, it will be high humidity. Why this condition? If it is going to be a tropical region, the receiving of insolation is high. So, if the insolation is high, there will be a excess of evaporation in the surface of the earth. Because of this reason, this that is in tropics, there is a high humidity, that is high water vapor content. What are all the sources which produce this water vapor? That is the evaporation, transpiration and sublimation. So, evaporation, so in the earth's surface, it may be the ocean area, it may be a river region, or it may be a pond or lake, or it may be any surface that can evaporate. So, because of this evaporation process, the rising of air which contributes to the water vapor. And what is meant by transpiration? The transpiration is nothing but it is the transpiration process which is happening in the green plants. In the green plant leaves, due to the porosity, what happens, that pores will be, that is the pores will assist in the transpiration process. That is the sublimation. The water vapor is not transferring into liquid, it directly solidifies. So, that process is known as sublimation. Where it happens? It happens in the ice crystals or the snows. The hilltops, this process is more evident, and then it drives, the water vapor drives the cloud formation and precipitation and weather patterns. So, without water vapor, there is no cloud formation, and without cloud formation, there is no precipitation. If there is no precipitation, there is no weather pattern existing in that particular region or throughout the earth's surface. So, what are all the types of humidity? There are three types of humidity, that is absolute humidity, relative humidity and specific humidity. So, we will be discussing one by one. So, what is meant by absolute humidity? The name itself implies that it is a actual amount of water vapor in air. So, whatever the amount of water vapor which is present in the air is considered to be the absolute humidity. So, what it is? That will be considered. So, this is known as absolute humidity. It is measured as grams of water, it is measured as grams of water vapor per cubic meter of air. That is, this is the most important thing, how the measurement have been done. So, the measurement process is done by grams of water vapor per cubic meter of air. It varies by location across the earth's surface, the varies by location. So, the humidity is not similar in all location, it varies. So, do not confuse that if it is going to be actual, the humidity will be same in all location, no. So, humidity varies according to the location, only the actual amount of water vapor in the air is constant, but the variation in location is witnessed in all the regions. The warm air holds more moisture than the cold air. So, here we are comparing warm air and cold air. So, this is mainly because the warm air hold more water vapor, because the evaporation process will be high in the warm air. So, because it is rising due to the temperature, increase in temperature, the warm air rises up and it leads to the evaporation and forms clouds. So, it can hold a huge amount of water vapor than the cold air. And next one is relative humidity. So, the relative humidity is a percentage. So, this percentage is most important. The percentage of moisture in the air which compared to its maximum capacity of the given temperature. See, look at this diagram, that the maximum capacity of this container, the glass is 100%. But what happened? In the first glass nothing is there, so it is 0%, and the next one the relative humidity is 50%. So, 50 divided by 100 into 100 will be the 50%. So, in percentage the relative humidity is calculated, and coming to the next glass it is a 75% of relative humidity. So, in such a way the humidity is calculated in percentage. So, for example, the next one you can see that the actual amount of water vapor, that is, if it is going to be actual amount of water vapor, what is that? It is the previously we have discussed, no, the absolute humidity, that is divided by humidity at saturated point. What is saturated point? That is maximum water vapor air can hold at given temperature. In a given temperature, how much amount of water vapor maximum can be hold? So, that is considered to be the saturated point. So, it is multiplied by 100. So, what process we have done here? That is explained here in the second paragraph. The most commonly used measure of humidity is relative humidity in the weather and climatic studies. So, if we consider the weather and climatic studies, this relative among these three, that is absolute humidity, relative humidity and specific humidity, relative humidity is mostly widely used humidity range, that is humidity pattern. Then relative humidity, the air temperature changes affect the moisture capacity and then the relative humidity. So, if the temperature changes, it is affecting the relative humidity. So, this is a constant one, and the relative humidity is higher over ocean. Why it is higher over ocean? Because of the vast water surfaces. If it is going to be have a huge amount of water, the evaporation process will be high ocean in comparison with the land surface. So, due to more water availability for evaporation, it is lower in the land surface, that is continent. So, here you can compare with the continentality. So, in the continentality, how the humidity pattern will be? The humidity pattern will be low, and then the humidity controls evaporation amount and rate and making it important climatic factor. Relative humidity is controlling what? All the climatic factor. So, it plays an important role. Without humidity, the entire weather process, climatic phenomena cannot be occurred in the atmosphere, that is lithosphere or atmosphere or biosphere. So, this relative humidity, that is especially the humidity, plays an important role. The air holding maximum moisture at the temperature is saturated with 100% relative humidity. So, saturated, what is meant by saturated? If you are going to eat a food which you like, so how long you can eat? Until your stomach is filled. So, apart from that, there is no space in your stomach. So, what it will be? That your stomach is saturated with the food which you like. So, the excess amount cannot be accepted by your stomach. So, that is the same concept you can apply here, that the saturated point is fully saturated, no excess amount can be added hereafter. So, that is the saturated point. Here when the temperature is saturated, what will be the relative humidity? That will be the 100%. So, this is most important, 100% in all the competitive exams you can expect. So, what is the relative humidity percentage? So, please concentrate on this. The saturated air cannot hold additional moisture at the temperature. So, the same thing, it cannot hold the excess amount of air. So, already it was filled. So, it cannot hold the excess amount of air. Relative humidity can be changed in two ways. So, what are the two ways? The first concept is the relative humidity changes by adding moisture. The second concept is changes the air temperature and alters the saturation point. So, these two important cases you have to consider while discussing about the relative humidity. The relative humidity changes by adding moisture. How it can add the moisture? By evaporation process, which increases absolute humidity and raises the relative humidity. So, this is the condition of adding moisture. If the moisture is not added, the case is vice versa, it is upside down. And the second concept, the second case is the changing air temperature alters the saturation point. Cooling lowers the moisture capacity, increases the relative humidity. So, what happens here? If it alters this adding of the temperature, air temperature will alter the saturation point as well as it lowers the moisture capacity. So, the capacity which hold is lowered, and what happened to the relative humidity? The relative humidity is increased. So, this will be a vice versa situation in warming of the temperature. The next one is dew point. That is, the dew point is nothing but it is a saturated air contains moisture at its full capacity. So, this full capacity is most important for a given temperature. For a specific temperature, the moisture content will be full. So, this is saturated level, the saturated air. So, that is considered to be the dew point. That is, at saturation, the air cannot hold any more moisture because of the fullest capacity. So, no addition can be done. So, the temperature when saturation occurs is called dew point. At which point the saturation occurs? That is known as dew point. The dew point reaches when relative humidity is 100%. So, here also we are coming again with the dew point, that is reaching when relative humidity is 100%. So, the relative humidity will be 100% in the dew point situation. Next one, the third humidity is the specific humidity is the weight of the water vapor per weight of the air. So, here you have weight by weight. So, the two numerator and denominator is in the same, that is weight and weight. So, it does not affect by any temperature change or any pressure change, air pressure change. It is measured in grams of the water vapor per kilograms of air. So, the grams and kilograms inversely it is related. So, it is coincides. So, whatever the affecting process, either it may be temperature or it may be a pressure, it does not affect the specific humidity. So, it is not affected by the change in pressure or temperature, unlike absolute and relative humidity. So, what we have discussed in the previous types, that is absolute and relative humidity, this will change according to the temperature and pressure, air pressure change. But here in the specific humidity, it is a constant, there is no change. The absolute and relative humidity vary with the condition, while specific humidity remains constant. So, this is the most important concept regarding the specific humidity. Humidity and climate, that is, in the high humidity is seen in which region? Tropical region, because of the increasing temperature. The evaporation process happens. Because of evaporation, the cloud formation also is the next stage, and then after cloud formation, heavy downpour, that is heavy rainfall is experienced in the humidity high region, especially this tropical regions. And low humidity. So, the low humidity in the desert region, which results in arid climate and scanty rainfall. It is opposite to that. Because of dryness, this low humidity is the that is adverse condition. Because of it, the desert region is very dry, it have an arid climate and scanty rainfall, low rainfall. It controls the heat index, making temperature feel hotter or cooler. So, in the previous lectures, we have discussed about the humidity which affects the comfortness of the human being. So, the same concept is applied here. It also controls the heat index. So, it is a determining factor. It drives the monsoon and precipitation cycle. The humidity is one of the important weather phenomena which determines the monsoon, whether the monsoon onset, monsoon will be there or not, will be determined by humidity, and whether there will be a precipitation, that is water cycle will be there, or there will be a cut in a water cycle, whatever the pattern, which will be determined by humidity. It also determines the biome distribution. Once the humidity is going to be a favorable situation, there will be a luxuriant vegetation. So, in the tropical region, you all know that the vegetation will be a luxuriant vegetation. So, it supports the vegetation in that particular region, that is humidity supports vegetation in that particular region. The factors affecting humidity, what are all the factors which affects the humidity? They are temperature, evaporation rate, precipitation, air mass origin and topography. So, these are all the factors which affects the humidity. The humidity and evaporation, how humidity and evaporation are correlated, linked with each other. That is, evaporation decreases when air is saturated with moisture. Yes, if this cloud is having a fullest water vapor, that is full of water vapor, it is dumped with it, it reached the saturation point, what happened? It could not accept the upcoming the evaporated water vapor again, because already it was saturated. So, this is one of the important factor. The low humidity leads to high evaporation, causing cooling effect. If it is going to be a low humidity, the effect will be cooling, and it also significantly it affects or manages the water resources and agricultural efficiently. If there is a water vapor and condensation process occurs, what happens? The next, it leads to the precipitation. If it leads to the precipitation, there will be a recharging of water bodies, and it also influences the positively influences the agriculture. So, in such a way, it plays a crucial role. The humidity plays a crucial role in water resource management and agricultural process. It influences, that is, the moisture loss from lakes, rivers and soil. Why there is a moisture loss? Because it is a evaporation process. If it is going to be evaporation process, there will be loss in the water bodies, because of heat it is evaporating. So, in this water body there will be a decrease of water vapor, and then in the next lecture we will be discussing about the condensation also. In that there will be a gain again, the water cycle. It is also important for designing cooling system and irrigation plants. So, if we know about the evaporation and humidity patterns, so it will be very much helpful for designing the cooling systems and then irrigation plants in that particular region. Humidity and evapotranspiration. So, the transpiration is nothing but it is from the plants, that is green leaves. It combined with evaporation, it is known as evapotranspiration. This evapotranspiration depends on air humidity. So, the air humidity plays an important role in this evapotranspiration. The low humidity causes high evapotranspiration, which leads to increased water loss from the plants. So, there will be a dry condition. So, if there is a excess loss of water in the plant, what happens? So, it will be dried, the plant will be dried. The high humidity reduces the evapotranspiration, which helps the plant to retain water. If the required water content is retained with the plant, there will be a blooming growth of plants and vegetation in that particular region because of humidity. It is also important for irrigation planning to manage water efficiency. So, in order to plan the irrigation and in order to use the water resources in efficient manner, this evaporation and humidity relationship should be understood by each and every one. It also directly impacts the crop yield and water resource management. So, if it is going to be a dry situation, it adversely affect the yield of the crop. If it is going to be a favorable situation, it give the huge production, the yield will be very high. So, this pattern should be understood. Humidity and air pressure. So, the low pressure causes air rises, cooling and condense, leading to high humidity. So, the low pressure is related with high humidity, and high pressure in this case the forces air to sinking air, that is because of the heaviness the air is sinking and it is warming and resulting in low humidity. So, low pressure it is related with high humidity, and if it is going to be high pressure, that is it is related to low humidity. So, this was the case of air pressure. It explains the cloudless skies, that is if it is going to be a high pressure, the anticyclone, imagine that is under the anticyclones what happens, the cloud, it is a clear sky situation. So, there is a cloudless skies and the area will be, the region will be high pressure region. It is also important to understand the storms and climatic patterns. The how storm occurs, it depends upon the humidity content, and how the climatic pattern differ from one place to another. It also depends upon the humidity content, whether it is a low humidity or high humidity. The interaction, its interaction with temperature influence the relative humidity levels. So, this relative humidity level is also correlated with the air pressure. Humidity and weather phenomena, that is the cloud forms with high humidity through condensation process. So, each and every weather phenomena requires some requisite condition. So, what are all the conditions for each and every weather phenomena is discussed here. That is the cloud form with high humidity, and then fog and dew occurs near saturation humidity. And if it is going to be a thunderstorm, what happens? It needs moist and unstable air. The conditions, look carefully about the conditions. And if it is going to be hurricane, where it gains the energy? Hurricane gains its energy from the ocean humidity. So, here you can see the hurricane from ocean, it is gaining the that is humidity. The humidity controls precipitation type and strength. So, in such a way the weather phenomena and humidity is highly influenced or correlated with each other. Importance in agriculture, that is humidity affects crop transpiration and growth, influence water use. That is the humidity, if it is going to be a low humidity, what happen? It have the stress, water stress situation. So, because of this water stress, the plant, consider the plant health, it is stunted growth, that is, it restrict the growth of the plant. So, this was the condition in the low humidity, and if it is going to be high humidity, it increases the risk of fungal disease in the crop. So, if the moisture content is high, the attack of the fungals, bacteria, fungus, all influence in the plant. So, because of that, it is affected, the plant is affected by disease. So, the ideal situation is required for the plant growth. And it is also important for planning irrigation schedules to optimize water use. So, if we plan carefully with the humidity and then the growth of the crop, so we can optimally use the water resources and irrigation pattern. It is important for the managing tropical versus arid crop requirements and yield. So, in order to manage the crop either in the tropical region or in the arid region, the knowledge about the humidity is most important. Importance in industries, that is, manufacturing need humidity control. So, it may be like a textile, paper or electronics industries. It maintains the quality by the temperature maintenance as well as the important factor is humidity. Enhances the quality of the products. Humidity maintenance enhances the quality of the product. The proper humidity prevents the spoilage in the storage of grain, pharmaceuticals and chemicals. For example, in the pickle bottle, if you are going to put the wetted spoon, what happens? The wetted spoon will form the fungus in the pickles. So, the moisture content is required for each and every product. So, the optimum moisture that is humidity is required for the perfect maintenance of the or quality maintenance of the product. So, in such a way the humidity plays a vital role. The humidity affects the energy system, especially the evaporative cooling efficiency. In the construction process also, it is most important for curing of cement and concrete, for solidification of cement and concrete. This humidity is most important. The aviation requires the humidity control for safety and comfort. So, in order to fly safe and in comfort, the aviation is also having, it plays important role in aviation sector also. Importance in health, that is, the low humidity causes a respiratory discomfort and skin dryness, and if it is going to be high humidity, it encourages the mold and bacterial growth, that is fungus and bacterial growth, and it also influences the spread of airborne diseases. Though the airborne diseases is the most important triggering factor of humidity. So, based on the humidity, the spread of disease will be there. The rise of heat stress and heat index is because of the range of humidity, and the hospital environments maintain 40 to 60% of relative humidity in order to maintain the patient in comfort zone. The next is the measurement of humidity. So, the humidity can be measured using various instruments. The first and foremost is psychometer. The psychometer consists of the wet and then dry bulb. So, this wet bulb and dry bulb have the thermometers, and the wet bulb cools due to evaporation, and it that is the difference between the wet and dry bulb, that is the readings indicates the humidity levels. So, the difference between the wet bulb and dry bulb, the difference shows the humidity levels. The simple widely used instrument, so this is the psychometer is the instrument which is used widely in order to measure the humidity. The measurement, that is the hygrometer. The next instrument is hygrometer. This hygrometer measures the relative humidity directly and in a precise manner. The types of hygrometer are mechanical hygrometer, electronic hygrometer, hair hygrometer. The hair hygrometer expands and contracts with moisture, which indicates the humidity. It is used in weather stations, greenhouses and industrial appliances, that is industrial applications. It provides the continuous humidity tracking for the effective control. So, next one is the electronic hygrometer. So, it is using the sensors to measure the water vapor content in precise manner. That is, it provides the facts and accurate digital readouts of the relative humidity. It is widely used in laboratories, industries and weather stations. It is often combined with the temperature sensors for the comfort monitoring. The satellite measurements. The satellite, that is the remote sensing technology, detects the water vapor in the atmosphere. So, with that data, what happens? It provides the detailed map of the humidity of the world, that is humidity distribution of the world. It helps to monitor clouds, precipitation potentials and climate change. The data is used in weather forecasting and climate models. So, it also work along with the ground based station in order to give the precise analysis about the humidity content. The next one is daily variation, that is the humidity is minimum in the afternoon. So, in the noon section it is minimum and it is maximum in the early morning. So, it will be maximum in the early morning. So, this inverse relationship to the it is inversely related to the temperature. When the temperature rises, humidity decreases, and it also controls the dew formation at the night times, and it is also important in the agriculture sector and then human comfort. This measurement is used using the daily hygrometric curves to show the diurnal variation. The diurnal variation is showed with the help of daily hygrometric curves. Then seasonal variation of humidity, that is the wet season have high humidity and dry season have low humidity. That is the monsoon season have the extreme seasonal humidity change. Why there is a extreme seasonal change? Because the monsoon is a seasonal wind. So, based on the seasons, this humidity is also varying. That is, it varies the humidity content in the monsoon region. It influences the plant growth cycles. It also affects the evaporation rates and then water resources of a particular region. It is most important in climate model predictions. How far it is important, humidity is important in humanity, that is, so it regulates the human comfort. If it is going to be a high humidity, it creates the muggy situation. It will be very warm, discomfortness will be created. So, this was the situation in the high humidity, and if it is going to be a low humidity, it creates the dry condition. So, because of that, it influences the weather patterns and climatic situation of the region. It also controls the evaporation and transpiration in the leaves, that is in the plants, crops. It supports agriculture and plant growths. It is also important in aviation, construction works and energy systems. To sum up with the entire lecture, that is, the humidity refers to the amount of water vapor present in the air. It varies with the temperature. If it is going to be a high in a warm condition in the which region, that is tropical region, and it is low in cold and desert areas. The humidity plays a vital role in cloud formation, rainfall pattern and human comfort and also the weather patterns, and it also strongly influences the climate and ecosystem distributions. So, with this we conclude with this lecture. In the upcoming lecture, we will be discussing on evaporation and condensation. Thank you.